To Miss Parv's Flipped Classroom. Today we're going to be talking about absolute value functions and their graphs, and the objective is to graph absolute value functions and, if we're given the graph, to be able to write the equation. Recall that the absolute value is the distance from zero, so if we have the absolute value indicated by these vertical lines here of -3, it's 3 because -3 is 3 places from zero. And the absolute value of 3 is also 3. The absolute value parent function is y equals the absolute value of x. And here we see if we have the x values -2, -1, 0, 1, and 2, then our corresponding y values would be 2, 1, 0, 1, and 2. And this is what our graph would look like. The absolute value graph is always a V that either opens up or down. The vertex is the point where these come together. And if it's the lowest point on the graph, it's called a minimum. If it's the highest point on your graph, it's called a maximum. And the vertex is given by the letters H, K. Your axis of symmetry in this graph is your y-axis, because if we flip this over, it would be exactly on top of the other side. We could cut it in half, fold it, and it would be exactly the same. And A is the slope of this line, which is the right branch of the graph. So here's your vertex. This would be the left branch. This would be the right branch. So if you find the slope of this side, that's equal to your A. Okay, recall your translations that we did on a previous slide. Vertical translations, remember, are your function plus or minus K. And vertical translations move your graph up or down. So on this one we have y equals the absolute value of x plus 2. So our graph is our parent function just moved up 2 places. On this one we have y equals the absolute value of x minus 2. So it's our parent function just moved down 2 places. Our horizontal translations are when we have x plus or minus h inside of the absolute value symbols. And remember, these are the opposite of what you might expect. If x is plus 2, we move 2 places to the left. If we have x minus 2, we move 2 places to the right. We also have vertical stretches and compressions. Your stretch is when your a is greater than 1, as in this example where a is 2. Your compression is when a is between 0 and 1, as in this one where we have a is 1/2. Notice your stretch took the parent function and made it tall and thin. Your compression took the parent function and applied pressure to squish it down and make it short and stubby. A reflection is just taking this and flipping it over. So if we folded this piece of paper along the x-axis, then this parent function would be on top of this reflection. This is a reflection across the x-axis because this is the point where we would fold it. A reflection across the y-axis, you would fold this way and then fold it over like this. And you can see that an absolute value function is already symmetric with respect to the y-axis because it would fold over on top of itself. The vertex form of the equation for an absolute value function is y equals a times the absolute value of x minus h plus k. Your vertex is hk. Notice that the minus is part of your formula. So whatever this is, you would take the opposite. So if this was a plus 2, then this would be a minus 2. So your vertex is your h and your k. Your axis of symmetry is always x equals your h. And the absolute value of a is your stretch and compression factor. And I just stated earlier that you find a by finding the slope of the right branch on your graph. Okay. Now we want to find the equation of an absolute value function from a graph. So we have this graph, and we know it's an absolute value function because it makes a V. The vertex is at the point 2, 3. Our axis of symmetry goes through the vertex, and the slope for this right hand side, we go up 2 and over 1, so the slope is 2. Putting all of this information together, along with our basic formula, we get y equals 2 because a was 2, x minus 2 because h of our vertex was 2, plus 3 because the k of the vertex was 3. The axis of symmetry is x equals 2, and our vertex is a minimum because it is the lowest point on the graph. So the equation for this graph is y equals 2 times the absolute value of x minus 2 plus 3. We took the parent function, moved it up 3, moved it right 2 places, and multiplied all the values by 2 to make it taller and thinner.